Condensed milk is a sweet, creamy ingredient made by heating milk to remove most of its water, then adding a large amount of sugar. Its rich flavor and smooth texture make countless desserts taste even better. But how is condensed milk made from fresh cow's milk? In this video, we will follow the entire process from the dairy farm to the finished can. Condensed milk was developed by American inventor Gale Borden in 1856. His invention helped solve one of the biggest food storage problems of the time: how to preserve milk before modern refrigeration. By removing much of the water and adding sugar, milk could remain sealed inside a can for at least a year. The product became especially valuable during the American Civil War. It gave soldiers a dependable source of milk in places where dairy cows were unavailable. The army valued condensed milk because it lasted a long time, was easy to transport, and provided useful nutrition to troops in the field. The production process begins on dairy farms. Most of the milk produced in the United States comes from roughly 60,000 dairy farms, where more than 9 million cows are raised for milk production. For more than a century, milking machines have been essential to this industry. The part of the machine that attaches to each teat is called a teat cup. It works somewhat like a human hand, applying gentle, repeated pressure to draw milk from the udder. A farmer milking by hand can handle about 6 cows per hour. With a milking machine, that number can rise to nearly 100. This technology has made milk production much faster and more efficient. But the quality of the milk also depends heavily on how well the cows are cared for. The better the animals are treated, the healthier they remain, the longer they live, and the more milk they can produce. This dairy farm is home to approximately 7,500 cows. It is one of many large farms that use technology to improve animal care while increasing production. Up to 80 cows can step onto 2 rotating platforms at the same time. These circular systems, known as rotary milking parlors, allow large groups of cows to be milked efficiently. The cows are usually milked twice every day. Dairy cows are creatures of habit. They prefer a consistent routine, which makes the milking process easier and helps reduce stress. Rotary parlors are also more efficient than many standard systems, increasing the speed of milk flow by around 30%. Before milking begins, workers clean each cow's teats with an iodine solution. This helps remove dirt and reduces the risk of bacteria entering the milk. The milking cups are then attached to the udder. Their pulsing action imitates the natural sucking motion of a calf and draws out the milk gently. The full process takes about 7 minutes. Once the milk flow falls to the correct level, the cups release automatically and the cow can leave the platform. A productive dairy cow may spend around 8 hours a day eating. She can consume approximately 100 pounds of feed and drink up to 79 gallons of water. That intake allows her to produce as much as 10 gallons of milk per day, 7 days a week. Today's dairy cows are around 3 times more productive than they were 50 years ago. This is partly the result of improved technology and partly the result of better, more carefully balanced diets. A dairy cow usually begins producing milk at around 2 years of age after giving birth to her first calf. On many commercial farms, the calf is separated from its mother shortly after birth. The calf is then fed milk from a bottle while the cow begins her milking cycle. Cows are generally milked at least twice a day for approximately 305 days. They are then given a rest period of about 60 days before giving birth to their next calf. After the calf is born, the milking cycle begins again. Cow's milk is a nutrient-rich liquid made up of about 87% water. Milk production begins when the cow digests her feed and breaks it down into nutrients. Those nutrients enter the bloodstream and are carried to the mammary glands, where they are used to produce milk. Fresh milk leaves the udder at roughly 90 degrees Fahrenheit. It is immediately pumped through sealed pipes into refrigerated storage tanks. These tanks quickly cool the milk and keep it between about 36 and 37 degrees Fahrenheit. At this point, the milk is still raw and may contain harmful bacteria. It is therefore transferred into insulated tanker trucks, each capable of carrying more than 5,000 gallons, and transported to a processing plant. To meet the enormous demand for condensed milk, facilities such as this Nestlé plant in California operate 24 hours a day, 7 days a week. This factory can process more than 422,000 gallons of milk every day. But how is fresh milk from thousands of farms transformed into thick, sweet, condensed milk? Tanker trucks arrive throughout the day carrying milk from nearby farms. Much of it was collected only about 6 hours earlier, so it is still extremely fresh. Even so, every load is tested in a laboratory before it is accepted. The milk's fat and solids content must meet the plant's standards. It must also be free from antibiotic residues, which could interfere with production and create a risk for people with certain allergies. After passing quality control, the milk is pumped into the plant's storage area. 12 enormous silos rise above the facility like futuristic towers. Together, they can hold approximately 740,000 gallons of milk, enough to produce nearly 20 million cans of condensed milk. The milk still contains more fat than the recipe requires, so it passes through a centrifugal separator. This machine can process more than 5,800 gallons per hour. Inside the separator, cone-shaped discs spin at an astonishing 7,000 revolutions per minute. The centrifugal force separates the milk according to density. The heavier skim milk moves outward, while the lighter cream moves toward the center. This produces cream with a much higher fat content and skim milk with very little fat. The skim milk becomes the main base used to make condensed milk. Next, the milk must be pasteurized to destroy harmful bacteria. It begins at approximately 37 degrees Fahrenheit and is pumped into a heat exchanger, where its temperature quickly rises to about 162 degrees Fahrenheit. The heated milk then enters a holding tube, where it remains for approximately 15.5 seconds. That is enough time to meet the standard pasteurization requirement. Afterward, the milk is cooled back down to approximately 37 degrees Fahrenheit. The entire pasteurization process takes less than 40 seconds and destroys about 99% of the bacteria present in the milk. Before pasteurization became common, much of the milk people consumed was raw. It spoiled quickly and could expose consumers to dangerous microorganisms. In 1862, French scientist Louis Pasteur developed a heating method to prevent wine from spoiling. The same basic principle was later applied to milk. Once the milk has been pasteurized, a large amount of sugar is added. The sugar provides sweetness, but it also acts as a preservative by making it much harder for microorganisms to grow. The mixture is heated again, so the sugar dissolves completely and spreads evenly through the milk. Careful temperature control also helps prevent large sugar crystals from forming, which could ruin the smooth texture of the finished product. The sweetened milk then enters an evaporator, a large machine designed to remove water. During this stage, roughly 60% of the water in the mixture is removed. The evaporator uses controlled heat and reduced pressure, allowing water to boil away at a lower temperature. This concentrates the milk without exposing it to excessive heat. As the water disappears, the proteins, sugars, fats, and other milk solids become more concentrated. This is what gives condensed milk its thick consistency and rich, sweet flavor. The evaporator is made up of several large sections called calandrias. Each calandria contains rows of stainless steel tubes. Milk flows through the tubes while steam circulates around them. The milk enters near the top and travels downward through the narrow tubes. As it moves, heat from the surrounding steam causes water inside the milk to turn into vapor. The milk becomes thicker with each stage of the process. Once the mixture reaches the required concentration, it leaves the evaporator and undergoes homogenization. During homogenization, fat droplets are broken into extremely small, evenly distributed particles. This prevents the fat from separating and rising to the surface. It also improves the product's texture, appearance, consistency, and stability during storage. Before the condensed milk can be packaged, the containers must be thoroughly cleaned and sterilized. Any microorganisms left inside could contaminate the product and shorten its shelf life. The finished condensed milk, now thick and creamy, is transferred to an automated filling machine. The machine dispenses a precise amount into each container, helping maintain a consistent weight while reducing spills and waste. Once filled, the containers are sealed tightly to prevent air, bacteria, or other contaminants from entering. But the safety process is not finished yet. The filled and sealed cans undergo one final heat treatment. They are loaded into industrial pressure vessels called autoclaves, where they are exposed to high-pressure steam. The combination of heat, pressure, and time destroys any remaining microorganisms. This final step helps ensure that the condensed milk inside each can is safe to consume and can remain shelf-stable for a long time. From a cow being milked on a dairy farm to a sealed can ready for use in desserts, condensed milk requires a carefully controlled series of steps. milking, cooling, testing, separation, pasteurization, sweetening, evaporation, homogenization, filling, sealing, and sterilization. Like the video if you enjoyed it and share it with someone who may find it interesting. Subscribe to the channel and turn on notifications to keep discovering how everyday products are made. See you next time.